Welcome to learning module number 10, the learning organization. So the learning organization is a vision of how a software development organization should look like, largely based on measurement, largely based on metrics and data. So it basically implements this continuous software process improvement idea that we heard about in the last lecture. So in this learning module, we will go into a deeper understanding how the learning organization works. We will learn about the software engineering reference model and how to build up an experience base that basically documents the experience of your organization and specifically containing measurement models, so the GQM models that we talked about in the whole lecture. So this learning module will also close the lecture in general. So we'll only have one final learning module summarizing everything and giving a little bit outlook to more related work. And I hope you will have fun in having finally a view on the bigger picture that brings together the different measurement models we learned about in the past. So let's get right into it.
So let's have a look to the learning goals of module number 10. First of all, we will learn about the general structure of the learning organization. We will then have a look to the improvement cycle connected with the learning organization and how this cycle works. The cycle basically distinguishes between project and organizational learning, so we can learn on two different levels. And if you remember from the last module, continuous software process improvement is always connected with having a concrete problem at hand, trying to quantify that, and then improve that over time, making use of this improvement cycle. And finally, we will take a look to the experience base. The experience base is a central element of the learning organization, and it contains all our measurement models that we can reuse in the context of the learning organization. So let's start with module number 10. Let us have a look to the general structure of the learning organization. And this structure that I would like to introduce is called the software engineering reference model, or the SE reference model. And as I said, the learning organization is a kind of ideal vision of a measurement-based organization that tries to capture all its experience, all its knowledge about processes, about products, about projects, the relationships between these things in an experience space, in explicit models. And this model was developed in the early 90s by Professor Rombach. He is currently, I think, a senior professor still here at university. He is retired from giving lectures. And so he and his fellow researchers developed this model, I think, when he still was in the US, partially at least. So basically, we distinguish between project organization on the one hand side that carries out all the development projects that are conducted in a specific organization. So of course there is not a single one. Maybe we have more projects running in parallel. And on the other hand side, we have the experience factory. So factory in the sense of that the central elements produced in this factory and stored in this factory is experience, and this experience is stored in a database. And basically all kind of experience may be stored in there. We have process models, so development processes that we follow, such as Scrum, Rational Unified Process, and so on. Maybe we have certain product models in there that we can make use of, templates, or maybe components that we can reuse. And the central element from the point of view of measurement are the quality models. So quality models in a more general sense, all kind of measurement models, all kind of relationships that we know about cost, time, effort, qualities, different qualities, reliability, maintainability. So basically you could put all the models that we learned about in the last learning modules into that experience database. And we can have many more things. We can have information about tools, methods, and techniques that we are using, handmade or ready-made products that we can reuse, as I said, reusable components, maybe project plans from previous projects that we can generalize and use for our purposes for new projects. And then basically, if we now start planning a new project, we will not start from scratch. We will basically pick the models from the experience database that fit to our project goals and characteristics and use that for creating a comprehensive project plan. So that makes use of the models, of the measurement models that we have stored in our experience base and is based on maybe previous project plans from similar projects that we already conducted in our organization. So based on that project plan, the project is executed, is conducted. So basically we follow our development process, we take our requirements and problem description, and we create our software product following this development process that you can see here in the middle of the picture. So, and this process is accompanied with project management and quality assurance activities. So we carry out the development activities like requirements analysis, architecture, implementation, testing, and so on and so forth. And we have some parallel activities related to project management and quality assurance. And based on that, we can store data, so the data from the metrics, the measures that we collect, the products that we create using our development process to a project-related database. And from that, we can also retrieve the data. So we have a little cycle here. And after the end of the project, we store the data in an experience factory. Maybe not all the data, maybe we have to generalize the data in order to be able to reuse that for future projects. So, which means we have a cycle here on that level. So we pick a model from the experience database, we use it in the project context, and then we basically check maybe we need to change something about the model, maybe we gain more trust in the model because we successfully applied it, but maybe also we need to change the model because it did not really work out for our specific project. And that's the general idea of the software engineering reference model. So the upper part is about systematic software development, and the lower part is basically about continuous learning and improvement. What are characteristics of the SE reference model? Well, as I said before, it supports continuous software process improvement based on the quality improvement paradigm improvement cycle, the QIP cycle. We have a clear separation between project-specific and organization-specific aspects. We have the project organization and the experience factory. Inside our experience database, we have an explicit modeling of products, processes, and other knowledge experience that the organization has collected over time from previous projects, maybe also from external sources that were put into the database. We can reuse these models in the planning step and instantiate the models to be used within a specific project context in the execution step. We have a gathering of measurement data to check our non-functional requirements, software requirements, also called quality requirements, and we can create new and improve existing models for our experience database. What are kinds of prerequisites for implementing this model? Well, basically you have to be able to establish systematic software development, so which means you have to establish explicit models, data-based, quantifiable models in order to improve also the predictability of your projects during project planning. So to have models that really work out, that give you some predictability of the project outcome. Measurement is a central element that the organization has to implement for successfully applying the software engineering reference model. That includes specifically indicators during the project execution and check whether you fulfill your quality requirements, whether you fulfill your project goals. Within the quality improvement paradigm, this is called the project-specific feedback cycle. And the second area you have to address is continuous learning and improvement. So you have to openly discuss about issues, deficiencies based on measurable experiences. So for instance, if you detect over and over again that you have problems with that too many defects slip through your testing stage to the customer, you have to address that and maybe introduce a new testing process for your projects. And last but not least, you have to be able to transform the experience, which is oftentimes only implicitly available in the project, into an explicit model that you store for being reused in future projects. That's called the organizational feedback cycle in the QIP, in the quality improvement paradigm. So how does the quality improvement paradigm look like? Well, it's basically consists of two improvement cycles. The outer cycle, the big cycle, starts with the characterization stage. So at this stage, you characterize your context, you characterize your organization that you would like to improve. Based on that, you set improvement goals, things you would like to obtain. You try to identify from the goals the metrics that are used for measuring goal attainment. Then you choose the projects that have to implement these metrics, that have to collect the data, that have to apply the models depending on what goals you have. So we're talking about measurement goals, for instance, specified according to GQM, the goal question metric paradigm. So you pick the projects that for trying that out. So for instance, you're in an organization and the goal is to reduce defect slippage because too many defects slip to the customer. So for that purpose, you have defined a new test process and you pick the projects that will try out the new test process. Then you will execute this new test process, for instance. So you will execute in general all the strategies. You will collect the data and apply the new techniques in the projects that you have selected beforehand. Again, for these projects, you will perform a kind of mini QIP. You will characterize the specific context of the project. You will set specific goals of the project. You will choose the process to be followed. So in this case, you will adapt the new test process to the specifics of the project. So maybe there is no big adaptation needed, but maybe there is, depending on your characterization, depending on your context. When you execute the new process, analyze the data from the new process, and then you package the data. And you do this for all the projects that you have selected. So basically you do then an analysis across all the projects that you have executed, and then you package that into your experience database. So let's have a look to the details of these two improvement cycles. The outer cycle is the organizational improvement across different projects. So as I said, it's about characterizing the organization, it's about defining improvement goals, it's about choosing pilot projects for your improvement, executing your ideas, so perform the projects, collect the data, analyze the projects, check whether your goals are reached. So during the goal stage, you may have defined some hypothesis. So I expect my new test process to have 50% less defect slippage. And of course, you will check that after trying it out, and then package your experience and maybe refine the models you have in your experience database. And the inner cycle, it's improvement on the project level. So you will go into more specifics regarding the characterization, the context of the project, what models fit, what project types. You will set the goals for the specific project. You will choose a suitable process, construct your project plan from that. You will perform the project, you will analyze the project results, and then you will adapt the experience base regarding that what can be learned from that specific project. So how can we map the quality improvement paradigm to the software engineering reference model? Well, that's quite brute force. We characterize our project and think about the goals at the very beginning during product goal and characteristics identification. Then based on that goals and characteristics, we choose appropriate models from our experience base and create our project plan. And we execute the project plan including the models that we have reused from our experience database. We analyze the project-specific data, and then we store the data in our experience base and maybe change elements from our experience base. So that's basically an easy mapping of the QIP cycle and specifically the project-specific QIP cycle to the software engineering reference model. So let's have an example of the outer and the inner improvement cycle. Let's start with the large outer improvement cycle regarding the overall organization. And in this example, let's assume we conduct a practical course in software development at the University of Kaiserslautern. And let's assume we have a problem with code quality because we have different programming experience and skills among the students participating in our practical course. The idea is then to use pair programming to improve the quality of software development because that helps to mix experienced programmers with unexperienced programmers. So the idea of pair programming is that you do not program for yourself. So that's a practice known from agile software development mostly, and it means that you combine software development specifically during coding implementation, and you normally have one person that is writing the code and another person that is checking the code, and maybe they will change their roles during a pair programming session. And in our specific case, you can use that to pair an experienced programmer with an inexperienced programmer and therefore try to level a little bit out the different experiences these people have. Then the GKM approach is chosen for collection and interpretation of the data, and we will pick some pilot projects for trying it out. So step number 2, setting goals. Our goal is to analyze the development process with the purpose of improvement with respect to found defects from the point of view of a computer science department chief in the context of a small student's programming project. Step number 3, choosing the projects. So a project or some projects are selected. We apply the new technique in the project. So in our example, pair programming, and we collect the data via some metrics defined by GKM. And then we can go into the lower cycle for the specific projects that we have selected. So in our example, we will shorten this up. So let's assume we applied pair programming as a new technique. We assess the programming skills of the team to have a balanced set of pairs of programmer, so always combining a more experienced person with a less experienced person. Then we go into this project-specific cycle. The goals are the same as for the outer QIP cycle. We select specifically the coding process for trying out our pair programming practice. We execute this idea, so the students make use of pair programming. We collect the data according to the metrics that we have defined, and we interpret the data according to our GQM model. And then steps 5 and 6 of the outer cycle again, we use the gathered information about pair programming across all pilot projects. We analyze the data. We probably have an organizational quality management that talks to the project manager and expects the measured data. And then we collect our experience, our knowledge that we have gained in the pilot projects, in our example about pair programming, in the reusable form. And then we can decide whether we introduce the new technique for all projects. So you can think about what data we might have collected based on the measurement goal that we have defined beforehand for assessing that we are able to produce code of better quality using pair programming. So think about our learning module about static code analysis, for instance. Let us have a look to a second example, now focusing more on the project-specific learning cycle. So in this case, we assume that we have an organization that conducts professional software development, has about 100 developers, a very high CMMI maturity level. And in their case, the measurement goal is to analyze the project plan regarding its accuracy. And they're doing that for a quality manager of the organization. And basically, the organization is specifically interested in effort and reliability models included in the project plan. And in the project-specific learning cycle, we have to now find an appropriate model in our experience base that fits to the project characteristics. And in our specific case, we have a project goal of having an effort less than or equal to 1,000 person hours, having a reliability of less than or equal to 5 failures per year of operation. The project is using a waterfall lifecycle model. We are using an object-oriented design approach, and the experience in the specific application domain is quite high. And this is basically used as a search criteria to the experience-based, and we check which models we have for that specific characteristic. And then probably we find a model or several models that fit to that. So we have our process model that we're using. So it's a waterfall process, the most simplest process that you can assume. So which means we run through each phase only once. So in this case, we have a development phase, we have a coding phase, and we have a testing phase, and we get some inputs and outputs of that phase. So X1 could be a requirements document that would be input for a development phase. Then we would have the architecture as X2, for instance, that goes in the coding stage. We have some code that is tested, and then we have probably the final product that we can deliver. And we have two models that fit to that. So the one measurement model is about the percent of effort that is required for each of these 3 stages. So the measurement model fits to the process model. So in this example, for instance, we assume that 40% of effort is used for development, 30% for coding, 30% for testing. And we have also some information about the percentage of found defects. So most defects are found in development stage, 50%, 20 in coding, 20 in testing, and 10% in use. So we can now use this quality model for further planning the project. So now we have to adopt the models that we have found to the specifics of the project. So in our case, we assume that based on the requirements, we performed some effort estimation and ended up with that we would require effort of less than or equal to 1,000 person hours. So we could scale the percentage of effort with this 1,000 person hours and would get 400, 300, and 300 person hours for development, coding, and testing, respectively. We have less than or equal to 5 failures per year of operation. So we assume that we have then 5 during the in-use defects found, and we can scale the other number of defects found accordingly for development, coding, and testing. So we end up basically with this effort model and its found defects model. Then we can now choose the process that we will perform. So we plan the process based on the project goals that we have identified in the previous step and the models that we have found. And now we can create our project plan that says, okay, for the development stage, we have an effort of less than or equal to 400 person hours, and we will probably find defects between 22 and 28. So to allow for some flexibility a little bit. And in the coding stage, we have an effort of less than or equal to 300, and we'll find defects between 8 and 12. And in the testing stage, we have an effort of less than or equal to 300, and we'll find defects between 8 and 12. So next, the plan is executed. So that means we perform our software development activities according to the process model used. So we develop our architecture, we do coding, we do testing, and in parallel we perform the analytical activities. So we gather the data, we analyze the data for project management, for quality management, and so on and so forth. We talk to the people for getting feedback, we need to interpret the data. And of course, when we talk about project management, we have to compare the actual data with the estimated data. And if we're lucky, the model will work as expected. So we can work with the originally planned effort of 400 person hours for developing the design, for 300 for coding, and 300 more for testing. But let's assume in our example, we needed twice as much effort for testing as originally planned. So 600 person hours instead of 300 person hours. So then, of course, we need to react in the context of the project. We need to update our project plan. We need to replan probably the delivery of the final software product is a little bit delayed, and so on and so forth. So in the analysis step now, we need to identify where the deviations from the original project plan came from. So what is the root cause for that? So in our example, we assume that the model for the defect finding, so if you remember, we had 2 models, the effort model and the defect model. So the defect model, let's assume that worked out as planned. And the effort model, as I've written on the past slide, let's assume we required twice as much effort as originally planned, as you can also see in the little illustration here, that actual value is 600 and the originally planned value was 300. So somehow we need to find the root cause for that. So for instance, we underestimated the testing effort because the application domain of the new customer, or we had a new customer, we thought we knew the application domain from a previous customer, but when we started the project, we realized that specifically regarding testing and quality assurance, we had to do much more to meet the reliability requirements than originally assumed. So our original context was wrong. So the domain knowledge was assumed to be high, but in reality it was low. We did underestimated testing effort for that reason. So somehow, so this is just an example, somehow we need to find the root cause of the deviation. Then we have to revise the project plan specifically for future projects so that we can learn from that. So for instance, the revised project plan will include a new effort model for our updated context. And we should also document the reasons for the revision. So why, so basically the root cause, why did we have to change the project plan? And finally, the packaging step now of the overall organizational QIP cycle. Again, we give all this what we generated in the context specific cycle and in the analysis to this packaging step, and we have to update our experience base accordingly. So which means from the project specific model, so from the updated model, we need to generalize the model again to make it applicable for other projects. So in this case, we have to transform again from absolute effort figures into relative effort figures. You see now we introduced a new effort model with some new context information, and specifically here this value was changed. The domain experience is low, and obviously for that specific context we need, in this example, twice as much testing effort as in the original model. Of course, as I said, this is just an example. So in another setting, of course, this may be different. Next, let us have a look how maintaining models in an experience base works. So basically, during the last steps of this organizational QIP, we will maintain our experience database. And how does this work? Well, we assume that we used, for instance, an effort model. So let's call this effort model number 1. And we used that model in a specific context, like experience is high, waterfall process, and so on and so forth. Let's assume for simplicity reason only experience is high. And we have a certain significance. So somehow we need to know, can we trust the model or not? And we can measure the significance in, I don't know, how many successful applications of the model we had. So if we applied it 10 times in the past, you would assume for that specific context, it will also work an 11th time. But if we only tried it out once and it worked, and we try it out the second time, then maybe the trust is a little bit less. So somehow we have to determine the significance of the model. And let's call the starting significance S, whether S is 10 or 5 or whatever, it doesn't matter. Let's assume that's the number of applications, successful applications. So then, of course, in the ideal case, the model works out perfectly. So we planned with 40% develop design effort, 30% coding effort, and 30% more testing effort. And in that case, of course, we can say, okay, we applied it once more successfully, so we can just increase the significance. However, there may also be the case that the effort model did not fit. So it did not work out as expected. Like in our example, we required much more effort for testing than originally expected. So we have a different distribution of the effort. In our example, one value in the context was wrong. So we assumed to have experience high, but in reality, maybe the experience was low. So in that case, we keep the original model with its original significance, plus we add another model with the significance 1, so just the starting significance. So maybe it was only applied once successfully now in that specific project context. So we have 2 models now in our experience space, one with the original context and one with the new adopted context. And of course, we have more cases here to consider. So maybe we forgot to document one variable. So one context is a very complex concept. So a couple of years ago, there was a research project at the University of Kaiserslautern, a large research project that was in essential about how to specify the context and what does belong to the context specification and what does not belong to the context specification. And that is a very complex question to answer, because you could put 100 attributes in your context specification and you still don't know whether you are complete. So This model tries a more pragmatic approach by saying, okay, maybe you find another criteria that distinguishes your context, like the original model turns out to work only for domain embedded systems, and maybe our new model will work for information systems. Yeah, so we simply forgot one important context characteristic. So in this case, essentially the same. We have two models in our experience space, the original one, which we still assume worked out for the original context, plus the extension that the domain must be embedded systems. Of course, we have to analyze that, whether for the previous S successful applications, the domain was over time embedded systems. Yeah, that needs to be made sure. And we're introducing maybe a new effort, model 3 in this example, with again a different distribution with a significance of 1. And last but not least, the fourth case, maybe the model was wrong. So in the past, maybe it was just luck that it worked out. So we have to rework the model. We have to throw away our past experience. So maybe this is not the best case, and maybe it's also not the most realistic case that the complete model was wrong, and we don't know why, basically. Yeah? So we have exactly the same context, but a different effort model, and we don't know why this is the case. So then we have to start from scratch and start with a new effort model, with a corrected effort model with an initial significance of 1. So this should illustrate a little bit for this example too, how maintaining a model in an experience base could end up. And on this slide, you see a little bit more generic version of exactly the same discussion. So now we are not talking about the effort model, and we are not talking about context experiences high. We're in general talking about a model and a specific context. And if everything works out, we simply can increase the significance of the same model for the same context. If the model does not fit, and we discover that one value of the context was wrong, we keep the original model and add a new model with a new context. This value of the context of context 1 is corrected, is changed. So you see that here. In the third case, we have to introduce a new context variable. So we have to extend context 1 a little bit and introduce a new model 3 with a new context. So for model 3, we have an added variable to the context. And last but not least, if the effort model was wrong, we are introducing a new model. We remove the old model from the database and store it with the initial significance as 0. And basically, we have 4 generic cases on how maintaining a model in an experience database can work out. And the model can be anything. Yeah, can be a specific measurement model for the effort, for the defects, for productivity, whatever model you want to store in an experience base. You can basically distinguish these 4 cases. So this is another look on the experience factory now from more an organizational structural perspective. So it's essentially the same picture as the software engineering reference model, but a little bit turned around. So if you look up the papers about the experience factory, you will probably find a picture that looks a little bit like that. But it's essentially the same. So you have the project organization here on the left-hand side, you have the experience organization on the right-hand side. And now you have the QIP basically mapped to this structure. So you start with characterizing the project context, setting the goals, choosing the process. You then execute the process. During that, you will use information from your experience space for setting up the original plan. You will reuse the models from the experience database. You will also store your experience, your knowledge created in the project back to the experience database. You will analyze the data and package the data. And this is also a quite nice addition here. You see that during the packaging step, you can generalize the data as we did. So you have a concrete effort model in our example that with absolute numbers, and we reconverted that to have relative numbers in there. Maybe during the packaging step, we might also have to tailor that to a specific situation. So maybe we can adopt the model to work for a specific target. Maybe we have informal experience that we can formalize. So maybe we create a checklist from effort drivers in the project. And maybe we have also to disseminate the models so that a broader set of people know about that model. We have to plan in some dissemination activities. So as I said, just for your information, another view on the structure of an experience base, essentially the software engineering reference model, but this is the picture that if you look into the papers, you will probably find that picture. So that's already the end of this learning module, so a very short one, and basically gives you a kind of vision, as I said, how an organization largely based on measurement, continuous software process improvement is structured, and containing also some more information about this experience database that stores all your measurement-based models, and you can reuse the models from that experience database. And of course, you can relate different GQM measurement goals again with that. So we could evaluate our experience database and the elements within the database, for instance, regarding their significance. So we want to know, can we trust the models, or what's the quality of the models that we have in our experience database? Yeah? We could evaluate the organization regarding whether they are learning from projects. We could evaluate, again, the experience database regarding how well the context is covered. So maybe for certain kinds of projects, we have a lot of models in our experience database, and for certain other kinds of models, we don't have certain other contexts, we don't have a good coverage, so we don't find models in our experience database at all. So these are more measurement goals from the viewpoint of an experience manager. And again, you can think about how could we measure that. We talked a little bit about significance. How could you evaluate the organization whether they are learning from projects at all? You can think about that. Or how could we try to cover the context that our organization is working in? So let's conclude that final learning module about the learning organization. We have seen that this quality improvement paradigm goes nicely hand in hand with that software engineering reference model and the experience factory concept. It describes a continuously learning organization based on measurement, based on models that we learned, that we created from data. Improvement can be conducted on the project level or on the organizational level. So we can perform project-based learning or organizational learning. And the quality improvement paradigm / experience factory allows for systematic reuse of measurement models according to in which context they are applicable and how much trust one may have in these models. That was exactly this significance concept. Regarding practical applicability, so well, that's a different story. If you look to the general concept, it's relatively old, and maybe I've only seen in my career only few companies who really tried to build up a generic experience base. But what I can say is that a lot of organizations try to build up something like an experience base for a specific field. So if you take the whole field of effort estimation, in general, if you want to build up models based on your own data, you essentially build up an experience database. This is what you're doing at the end. So if you collect data in general, if you collect measurement data for your organization and you think a little bit surrounding the typical project level. Yeah? So a little bit towards the organization and how the organization could evolve, then you somehow have to build up an experience database. Whether it's that formal as described in Basilis and Rombach's work, that's another story. But to implement this idea is, I think, a key element of reaching a certain maturity in terms of measurement. And as we have seen in the last learning module, it's for sure something that you have to implement if you want to reach higher maturity models. So neither CMMI nor SPICE say you have to implement an experience factory. They just say, okay, if you want to reach higher maturity levels, so statistically managed, optimizing, and so on and so forth, then you have to perform measurement on a strategic level. You have to think about how the organization can evolve using measurement. And this is what the Experience Factory and QIP is essentially about. So you find some papers, specifically also very nice papers about the origins of goal-oriented measurement and the Experience Factory concept, the quality improvement paradigm, comprehensive reuse models, and things like that on the homepage of Victor Basili. So if you follow the link there and go further to the section of publications, you have a quite nice overview of all this legacy of software measurement aspects. So really the basics that were described at that time. So yeah, I hope this was a good conclusion towards the end of this learning module and trying to bring everything together into more an organizational view, how the different models could play together as a vision of a measurement-based, improvement-oriented organization. So that's it for this learning module. In the next learning module, we will conclude everything and have also a look to more related work. So thank you very much for your attention and hope you also will join me for the very last module of this lecture. Goodbye.